So to calculate the moment of inertia, what you need first to calculate the moment of inertia, the first thing that you need is the location of the centroid. Where is the centroid located? To calculate the location of the centroid, you can roughly say that it is somewhere over here, but we don't know for sure how much it is. So let's calculate it by considering the location as y bar. Let's call it y bar from the bottom fiber. So to calculate y bar, what you essentially do is to take the moment of each area, you split it into different uh, areas. In this case, you can split this into one area, this into another rectangle, and this into another rectangle, and then just take the moment of the areas. So when I take the moment of the areas, for example, the first one, it is 120 times 10 times, I'm sorry, I'm taking the, yeah, I'm taking it is 120 times 10 times what? This total length up to this, the centroid of this particular uh, shape or the rectangle is in the middle. So you have 20 plus 470 plus 5. So you have 20 plus 470 plus 5 plus, and the next area that you need to take is this one. So the area is 15 times the whole length is 470 times the distance between the centroid to this point. So that is basically 20 plus 470 over 2. Plus you also have a third area, which is this one. And to calculate the area, it is just 150 times 2, 20 times the centroid is located for this small area. The centroid is over here and the distance is just 10 divided by the total area. The total area of the cross section, so which is 120 times 10 plus 15 times 470 plus 150 times 20. Now this gives you the location of the centroid in the y direction. In the x direction, you already know where it is. It is in exact in the middle. So you get this value as 215.26. Now you can call this as y bottom. Okay, to get the y top, what we do is just y top is just the total, which is minus the y bottom, and you get it as 284.74. Now you can see that this is the y max. You had two y values, y top and y bottom, and this is y max. Now you need this y max to calculate the elastic modulus. Now we have to calculate the moment of inertia. To calculate the moment of inertia, we have to use the concept of parallel axis theorem. Okay, because if you split this entire cross section into different areas, you can see that the moment of inertia, the centroid of this particular small area is over here, but the centroid of the entire cross section is somewhere else. So you need to transfer the moment of inertia to this point, to this axis. For that, what we do is, suppose you have ixx will be equal to what? Let's call this as x1 x1 for this element. So it will be I x1 x1 plus, what is it, a h square. A is the area of the small region, and h is the distance between the centroid of the small area and the centroid of the entire cross section, which which we just found a few moments ago. That is this one from the top. So likewise, we need to calculate the ixx of different areas and then sum it up. Now let's do that in the next step. So to calculate the Ixx of the entire section, we have to calculate, first consider this small area. Now, what is the moment of inertia of this rectangular cross section? You know that if if you have a rectangular cross section, if B and this is D, your moment of inertia I is equal to BDQ by 12. Now, besides BDQ by 12, you also have to add AH square to transfer the moment of inertia. So we have 120 times 10 cube by 12 plus 120 times 10, which is this area. That is, I told earlier it is A, and the h square is the distance between this and the centroid of the entire cross section. So it will be 284.74 minus 5. That is, this is 10. So you subtract, you need to get this. You know that this entire up to the centroid is 284.74. So you have to subtract that 5 out, and this time this will be a square. And the next term is this second rectangular area. So that will be 15 times 470 cube by 12 plus 15 times 470. And you have to find the distance between the centroid of this cross section of the entire cross section and the centroid of the small region, which you get to be 470 by 2 plus 10 minus 284.74 the whole square. And similarly for the last area, you get 150 times 20 cube divided by 12 plus 150 times 20 times 215. This time around I'm taking the length from the bottom, and you have 215.26 minus 10 whole square, and then you get a value of 3613229. I'm sorry, 50.5 mm to the power 4, and that you can simplify it as 3.613 times 10 power 8 mm to the power 4.